Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology and Autonomous Institution, Coimbatore. In this YouTube video, I am going to discuss the 19 ECB 301 Analog and Digital Communication subject under the topic Pulse with Modulation. So, I have already discussed pulse amplitude modulation, pulse position modulation in my previous YouTube video. If you have any doubt, kindly watch this playlist to know about pulse amplitude modulation and pulse position modulation. Now I am going to discuss the pulse width modulation. A modulation techniques where the width of the pulses of the pulsar carrier wave is changed according to the modulating signal is known as pulse width modulation. It is also known as pulse duration modulation. In pulse duration modulation, the amplitude of the pulses is kept constant and only the variations in width is noticed, as the information component is present in width of the pulses. Thus, during signal transmission, the signal undergoes pulse width modulation. Due to constant amplitude property, it gets less affected by noise. However, during transmission channel, noise introduces some variations in amplitude as it is additive in nature. But that is totally easy to removable at the receiver by making use of the limiter circuit. So this is the generation of PWM signal. The message signal and the carrier signal waveform is fed to the modulator, which generates the pulse amplitude modulated signal. This pulse amplitude modulated signal is fed to the non-inverting terminal of the comparator. A ramp signal generated by a sawtooth generator is fed to the inverting terminal of the comparator. These two terminals are added and compared with the reference voltage of the comparator circuit. The level of the comparator is so adjusted to have the interaction of the reference with the slope of the waveform. The pulse width modulated pulses begins with the leading edge of the ramp signal and the width of the pulse is determined by the comparator circuit. Here the first image shows the waveform of the sinusoidal modulating signal and the second one shows the pulse carrier after modulation. A PAM signal is generated that is shown in the figure C. This PAM signal when added with the ramp signal shown in D is compared with the reference voltage as the comparator shown in figure E. Lastly, figure F shows the pulse with modulated signal. We have already mentioned that the width of the pulses is directly dependent on the portion of the waveform that lies above the comparator level. This is how a pulse width modulated signal is generated. Detection of pulse width modulated signal. The figure shows the pulse width modulation detected circuit that provides the original message signal from the modulator. Some noise get added to the pulse width modulation signal. So firstly, to remove the noise introduced by the transmitted signal and the incoming signal fed to a pulse generator. This regenerates the pulse width modulated signal. This regenerated pulse width modulated pulse is then given to a reference pulse generator that generates pulses of constant amplitude along with constant width. The regenerated pulses are also given to the ramp signal generator that generates a ramp signal of constant slope whose duration is similar to the pulse duration. Thus, we have ramp signal height proportional to the pulse width modulated pulse width. The constant amplitude pulses are then provided to summation unit in order to get added with the ramp signal. The added output is then fed back to a clipper. This clips of the signal up to its threshold value, thereby generating a PAM signal as its output. This PAM signal is then given to low pass filter in order to generate the original message signal from the modulated one. Pulse width modulation advantages. It is more immune to channel induced noise than PAM. As noise adds to the amplitude, thus a reconstruction of PWM signal from distorted PWM signal is somewhat easy. The transmission and reception do not need to be synchronized. Drawbacks. Due to changing width of the pulses, variations in transmitted power is also noticed. Bandwidth requirement in case of PWM is somewhat larger than PAM. Applications. It is used in telecommunication, brightness controlling, over light or speed controlling of fans in some real-time applications. Detection of PWM signal. Next I plan to access. So in this YouTube video I discussed what is meant by pulse width modulation signal and how it is generated and how it is detected. Then application advantages and drawbacks of pulse width modulation is detected. Next YouTube video I am going to discuss with the some of the modulation techniques available in analog communication. Thank you.